Here we go. Fantastic. So we left off by talking about this normal distribution. And we said that we can track how many standard deviations, and we had this 68, 95, 99.7 that said, gave rough percentages that were between certain amounts of standard deviations away. And then what we said is, what if it's somewhere in between the standard deviations? And I ended by saying that we can use a z-score. So let's talk about exactly how we would be able to do that. And we're going to use a new example. We're going to use a new example here to do this. And each time, you're going to draw a picture. So there's your normal curve. And we have the circumferences of oranges having an approximately normal distribution with a mean of 20 and a standard deviation of 4. So that means what number is going to go at the center here? 20. And then just to the right of it is going to be 24, another standard deviation to the right. Then next is going to be 28. And then moving to the left, we would have 16 and 12. I always track 2 standard deviations on either side. So, first question is asking, what proportion of oranges have circumferences less than 18? So since it's not exactly at a standard deviation, then we're going to need to do something different here. All right. Less than 18, so where is 18? 18, it would be halfway between 16 and 20. So here's 18. And we want go to the left or right? To the left, since we want everything less than 18. We're going to shade everything to the left. So remember, this picture can help you get a visual of about how much area you might be looking at. So I know that this is above or below half of the data. It's less than half of the data. So our answer should be less than 0.5. But let's think about how we're going to get this. So we have our z-score is 18 minus the mean, which is 20, over our standard deviation, which is 4. So value minus the mean over the standard deviation. (18 minus 20 is negative 2 over 4, so negative 1/2. Okay. So our z-score is negative 0.5. It should be a negative z-score because we're below the mean. Below the mean should have a negative z-score. Now, what we're going to use is a table of z-score values to give us the proportion. So there should be a table. There should be some tables in the back of your textbook, at the very back of your book. And it should say Table A, Standard Normal Probabilities. There's 2 pages of it. And so this will give you all the proportions to the nearest hundredth of these values. And so by the AP test, you will need to have this table memorized. I'm just kidding. But you will need to know how to use this table. You'll need to know, what you will need to know is how to use this table and how to say, if I have this z-score, this is the proportion that you'll need.
Such a straight face. The delivery on that was evil, Mr. Fox.
So good. So easy. I mean, if you want to memorize it, then go for it. All right. So here's how this table works. I'm going to pull up a virtual one here so that you can see. So here I have a table of z-scores. And what this will do is that you can start by finding your nearest tenth, and then on the right-hand column, you will have the nearest hundredth. All right, so if I want negative 0.5, there's going to be one of the pages is the negative values for z-scores, and one of the pages is the positive values. So you'll notice that a z-score of 0.00 would be exactly 0.5, which should make sense, so half the data. This gives all the values to the left of that z-score. All the values to the left of that z-score. And you can remember that by the fact that it shades all the stuff to the left in the table. So what you want to do is, we had a negative 0.5 as our z-score. So we are going to go to negative 0.5, and I want negative 0.50, since it was exactly negative 0.5. So I'm going to go into 0.00 column. So negative 0.50 is 0.3085. So that's our proportion, 0.3085. Yes. I'll get to that in just a second. So that's the probability that z is less than negative 0.5, which is, what was it, 0.3085. Sorry, I'm rusty on my memorization of the table that I definitely have memorized. All right. So that's how we get everything to the left. So 0.3085, so about 30 or 31%. Questions on that so far? Okay. I'm going to change the question on number 2 so that we're not answering the exact same question again. Have circumference greater than 18 centimeters. So this time we want the probability that our oranges are greater than 18, which is the probability that z is greater than negative 0.5. It's going to be the exact same z-score with the exact same formula, value minus mean over standard deviation, but this time we want everything greater than it. So instead of shading to the left, we would shade everything to the right instead. So if I had about 30% of the data to the left, how much of it is to the right? It would be about 70%. So basically what I'm going to do is I'm going to take 1 minus the probability that we are less than. So 1 minus 0.3085. Because the table doesn't give you the values to the right. The table gives you the values to the left. So if you need some things greater, then we're going to shade everything that's to the right of that value. 1 minus 0.3085, which is going to be 0.15. Did I subtract that correctly? Okay, good. Very quickly, you can also do this on the calculator. How do we want to see that? Do you want me to go back and forth between the calculator and the table and show you both for each problem? Or do we want to just do everything with the table and then go back and show everything with the calculator? Which one's? Okay, that's what I was thinking. I just wanted to double check and see. I think that would be the easier way to organize it. Because the calculator can do all of this as well. Which is another reason you don't need to memorize the table. Okay. I think last year I did it with, if you go to table, I think it's table D, right? There's a table of random digits somewhere in here. And I think the table of random digits is what I did that with last year when I was like, you have to memorize this table of random numbers. Okay. Next, circumference greater than 25, so we're going to draw the same curve. This is what I want you to try. And again, this is another reason the diagram is helpful. I'm going to be asking you to draw the diagram on all these because I think it's really helpful for you to get that visual idea. Let me put it this way. On years, I started by requiring the diagram, and this chapter went really well, and people remembered the things that were going on in it. And then I was a little, I went a little easier on requiring the diagrams and didn't require them as much. And then suddenly people were forgetting what to do. So draw the diagrams. It's going to help you. They're a pain, but they're very helpful, especially early on as we go through this chapter to understanding what's going on. So shading everything to the right. Another reason this diagram is helpful is that you should see that it's going to be 1 and a bit, right? That your z-score should be a little bit bigger than 1, just from where you put 25 in that diagram. You should know it's greater, shade everything to the right. You should know that your answer is going to be less than 0.5. So that can help give you a clue of when I go to 1.25 here, positive 1.25, so I want the positive end of the z-scores. So let's see, we have 1.0, and I want to track, here's 1.25, so I want 1.20, 1, 2, 3, 4, 5. Here's 1.25. I want to highlight, but it won't let me. 0.8944. And so the other thing the visual can do can be like, oh, wait a second, 0.8944, that seems really high. That seems really high. That's way too high. And so I know that's not the answer. Oh, right, that's because we're looking at everything bigger, so I want to take 1 minus the 0.8944. I just tabbed to the same tab. 1 minus. All right, here comes the mental math again. There we go. 0.1056. Questions on that so far? Okay. Next one. here's what we're going to do. Tomorrow at the meeting, I usually at around this point, I give a quiz to make sure that we know all our stuff and we're relatively prepared. What I'm going to do is that tomorrow, one of the things I'm going to do, I'm going to finish up these notes, but I'm also going to go through that quiz and talk through it, and we'll do it together, and then you'll turn it in. So if you're at the meeting, then you'll have it done. If you're not at the meeting, then you're going to have to do it on your own and turn it in. So please be there. Between 17 and 19. Again, we should be able to get a rough idea of about what that percentage is. All right, between two values. Let me start by saying this is the thing that the table is bad at and the calculator is good at. But we can still do it with the table. So I want you to get the z-score for 17 and a z-score for 19. And visually, what we're going to do to get our answer is that I'm going to have two values. And all the table can tell me is everything to the left of whatever value I want. So if I have these two z-scores, I can get everything to the left of this value, and I can get everything to the left of this value. So if I just want the part in blue, what am I going to do to get that blue value? I can subtract. I can say that I have all this area. Okay, I can take all this area, and then I can take away the stuff I don't want over here. And what I'm going to be left with is the area that I do want that I'm shading in between. That's the way to do it from the table. Right, negative 0.75 and negative 0.25. Yes? Okay. So we want to the left of the negative 0.75, so find that in your table. To the left of negative 0.75. The negative values. 0.70, 0.71, 0.72, 0.73, 0.74, 0.75, 0.2266. Oh, sorry. This is 0.2266. Then what is my 0.25? 0.4013. We agree with that? Anyone have trouble finding it? Okay. So we are going to say the probability that x is between 17 and 19 equals, we're going to subtract these two. We're going to take 0.4013 minus the 0.2266. And I'm lazy and don't want to do that subtraction. What is it? 17. Can't write. 0.1747. So again, if we want between two values, we're going to take everything to the left of the rightmost value and subtract everything to the left of the leftmost value. Because that'll take away the stuff over here on the left side we don't want. And just be left with the stuff in the middle. Questions on that? Ready for the calculator? Let's do the calculator. On your calculator, the menu for this is going to be called the distribution menu. In this case, we're looking at a normal distribution. So we are going to have a distribution menu, which is in second vars. Second and vars. And the thing that we want here is going to be the second option. Normal PDF gives an exact value, which we're never going to use. Normal CDF is what we're going to be using. Normal CDF. There's going to be other things in this menu that we're going to end up using later, but for today, normal CDF is the one we're going to use. Then it asks lower, upper, mean, standard deviation. First off, mean and standard deviation. If we're looking at z-scores, and that's what it defaults to, if you're looking at z-scores and you got the z-scores, mean is 0, standard deviation is 1. That's what it sets it to automatically. Lower gives what's the lowest value, and upper gives what's the highest value. So it's kind of like if you think about like your domain and range that you put your interval notation in, that's kind of what it's asking you to do here. All right? So if I want everything, so we had negative 0.5, right? We had z less than negative 0.5. Wanted everything to the left of negative 0.5. So our rough sketch was like this. Right? What is the leftmost value? If you were in interval notation, what would you put on the left? Negative infinity, right? As far to the left as we can have. And then what would you put as the rightmost value? Well, 18 if we're looking there, if we're looking at z-scores, then our z-score that we found, right? Negative 0.5. So in the calculator, I always say to put a really, infinity, negative infinity, but as long as we're putting a really big negative number, that'll be good enough. Upper, our largest value that we want is negative 0.5. Z-score, so mean is 0, standard deviation 1. 0.3085. Everyone getting 0.3085? Okay. Let's do the next one. The next one asked greater than 18. Remember, we changed the number. Greater than 18. So this time I want everything to the right. So what is the lowest value I want to deal with? Where do we start? From left to right. So negative 0.5. And then everything to the right. So we go second vars. We go to normal CDF. Normal CDF. This time our lower is negative 0.5. And then our upper, how big do we want it? As big as possible, so we're going to put a really big number in. Mean is 0, standard deviation of 1. About 0.6915. Same thing we got.
So if we come to something on the AP test, will you have this table in front of us?
You'll have the table in front of you.
Oh, we will?
Yes, you will. But you can use a calculator to get it as well.
Yeah.
It's just a preference thing,
Uh-huh.
which one you find easier to work with. Let me show you the last one so that you can see it, and then we'll clean up. Okay. Between 17 and 19, what was the lower z-score we wanted?
17.
Well, the z-score was negative 0.75. That was the lower. And then our upper was negative 0.25. This is the last problem we just did. So you can just put, I want from here to here, my lower and my upper. Mean is 0, standard deviation of 1. So we don't have to worry about the higher and the lower and subtracting them. We can just put it in, and there's your answer. That's why I say the calculator does this nicer than the table does.